Welcome to Area and Mixed Numbers. Area can help us when we are multiplying mixed numbers, area itself and area models. You can use square tiles with side links that are unit fractions to find the area of a rectangle and to help you multiply. All right, we are going to look at an area model for this mixed number multiplication problem. 1 3/5 times 2 3/4. So, 1, first I need to divide my rectangle, and 3/5. I just broke this fraction apart, or mixed number apart, and then we have 2 plus 3/4. And now I am going to multiply the different pieces. So this is 1 times 2, and the answer to that is 2. And now I'm going to do 1 times 3/4, and 1 times 3/4. Any number times 1 is itself, is 3/4. And here I have 2 times 3/5. So I just put the 1 underneath the 2. 2 times 3 is 6/5. And let me see if I can make that stand out. 6/5. And then I have 3/5 times 3/4. And remember, I just multiply straight across. And I have 3 times 3 is 9, and 5 times 4 is 20. So in black, I have the 4 important numbers that I now have to add. I have 2 plus 3/4 plus 6/5, which is a fraction greater than 1, plus 9/20. Now, I have 3 fractions that all have different denominators, and I need to add them. So I have to make them have the same denominator. So if I played multiple with those numbers, I'm going to find that they have 20 in common. I can make all of those denominators, all of those fractions, have a denominator of 20. So 4 times 5 is 20, and 3 times 5 is 15. 5 times 4 is 20, and 6 times 4 is 24. And I don't have to do anything to this fraction because 20 times 1 is 20, and 9 times 1 is 9. I'm adding all of those fractions, but I also have this 2 that is a whole number. So 15 plus 24 plus 9. And I might just do this out to the side. 15 plus 24 plus 9. 5 and 4 are 9, plus 9 is 18, 2, 3, 4. So I have 48/20. Plus I have this 2. 2 and 48/20. Well, I can't leave 48/20 that way. First of all, I can divide and simplify it. And second of all, that's a fraction greater than 1. I think I'm going to divide 48 by 20. It's going to go in 2 times. 2 times 20 is 40. 8/20. So I have 2 and 8/20 plus this other 2 that I had. So now I have 4 and 8/20. And I can't leave my answer as 8/20 because they can both be divided by 4. So 8 divided by 4 is 2. 20 divided by 4 is 5, and I had 4. 4 and 2/5. That's using an area model, and that seems like an awful lot of work. I'm going to show you a different way to do that. But first I have to erase everything else that I've done on this page. So I'm going to pause for a second, do that, and come back to you. Alright, so I didn't erase everything. But I had 1 3/5 times 2 3/4. The first thing I'm going to do, if I do this another method, I'm changing both of these mixed numbers into fractions greater than 1. I do that by multiplying 5 times 1 is 5 plus 3. So it looks like this. So here's my number, 1 3/5. I multiply times 1, then I add the 3. So 5 times 1 is 5, plus 3 is 8. So I have 8/5. 4 times 2 is 8, plus 3 is 11. And then I have my same denominator, 4ths. Now I'm multiplying these fractions, so I can just multiply them. 8 times 11 is 88. And 5 times 4 is 20. Now I can just divide 20 into 88. 20 goes into 88 20, 40, 60, 84 times. I get 80. When I subtract, I get 8, 4 and 8/20. And then I am going to simplify by dividing 8 by 4 and 20 by 4. And when I do that, I'm going to get that familiar answer of 4, and 8 divided by 4 was 2. 20 divided by 4 is 5. 4 and 2/5. I hope you see that that is definitely easier. All right, here's another problem for us. 1 3/4 times 2 1/2. So with an area model, I'm going to break this up into 1 plus 3/4. This is so many more steps. You don't win any awards for doing more steps, but this is a method. So 1 times 2 is 2, and 1 times 1/2 is 1/2. 2 times 3/4, I have to write it down to do it. 2 times 3 is 6. 1 times 4 is 4. So I'm going to circle that. 3/4 times 1/2. 3 times 1 is 3. 4 times 2 is 8. So now I have to add 2 plus 1/2 plus 6/4 plus 3/8. All right, hopefully you can see that you could make them all have a denominator of 8. So if I make 1/2 have a denominator of 8, 2 times 4, 1 times 4, 4/8. 4 times 2, 6 times 2. And then this one gets to stay the same, and I still have that too. So now 12 plus 3 plus 4. 12 plus 4 is 16. 17, 18, 19, 19/8. So I have 2 and 19/8. Well, I can't leave it 19/8. So 8 goes into 19 2 times. 2 and 3/8 plus the 2 I started with. So 4 and 3/8. Okay, let's just check. I think the other way is easier. 4 times 1 is 4, 5, 6, 7. 7 fourths. 2 times 2 is 4, plus 1 is 5. 5 halves. 7 times 5 is 35. Let me erase a little bit over here. Okay, 7 times 5 is 35. 4 times 2 is 8. 8 goes into 35. 4 times. Oh, but yeah, look at there. 4 and 3/8 with a lot less work. So, I'm going to recommend that we just stick with changing our improper fractions, our mixed numbers to improper fractions, or our mixed numbers to fractions that are greater than 1. Call them improper fractions. Okay, so 1 and 1/9 times 1 and 2/3. So remember, it is, if you have 1 and 1/9, it is 9 times 1 plus this one in the circle, this direction, and you have the same denominator you started with. So 9 times 1 is 9 plus 1 is 10. 10 ninths. And then we have 1 and 2/3. 3 times 1, 3, plus 2 is 5, and we have the same denominator, 5/3. 10 times 5 is 50. 9 times 3 is 27. So now we have 50 27s. We obviously can't leave anything like that. Ooh, that's not erasing. Okay, so 50 27ths. 50 divided by 27. It's only going to go in one time. 1 times 27 is 27. When I subtract, I get 1 and 23 27ths. I'm done because 23, the only thing that goes into 23 is 1 and 23, and 23 does not go into 27. Alright, here's your homework. Do yourself a favor. Do not draw an area model. You need to recognize the area model. If you see that someone has started an area model, like on a test, you would need to know how to finish it or recognize it, or recognize if you saw 3 area models drawn for this problem, which one is the correct area model. But don't try and solve them that way. It takes too much time, and there is so much room for error. Go ahead and turn these mixed numbers into improper fractions or fractions greater than 1 and solve them that way. Remember, when people like me, who are 1,000,000 years old, were younger, we called those improper fractions, and now we call them fractions greater than 1. So, have a great night.